Hi, in this video I'm going to show you how to calculate the expected value given a probability distribution, and then we'll also do the variance and standard deviation. Okay, so here we have a different example. It's not the lottery ticket. We're going to work up to that one. We have a coffee shop, and they've tracked their morning sales of cups of coffee and observed the following distribution. So after getting some data, they found that they sell 145 cups of coffee 15% of the time, and 150 cups of coffee 22% of the time, 155 37% of the time, and so on. Now this is a probability model or probability distribution because we have a variable x, the cups of coffee in this case, and then we have the chance or probability excuse me, of each one occurring. So these probabilities have to add up to 1.0 or 100%, right? That's the only way it would make sense. You can't have part of the time where nothing happens, or, you know, you have to add up to 100% of the time. Okay, so remember the expected value is a long run average, and I'll get to this, all these symbols after we go through the procedure. The expected value is the long run average or mean, so that's why we use the symbol mu. We also use E of x for expected value, the expected value of this variable x. Okay, so what we're going to do is we're going to take the number of cups of coffee times the probability that that will occur. So 145 cups times 0.15 plus 150 times 0.22. Essentially, this is a weighted average. Each one of these numbers isn't equally likely to occur, so we're not going to just add them up and divide by 5. We're weighting them by the proportion or the percentage that they occur. So you can see the 145 is going to get a little less weight. The 155 is going to count the most, and the 170 is going to count the least. Okay, so let's keep going. 155 times 0.37 plus 160 times 0.19 plus 170 times 0.07. Okay, so let's add these up. 145 times 0.15 150 times 0.22 plus 155 times 0.37 plus 160 times 0.19 plus 170 times 0.07. Okay, I got 154.4 cups of coffee. Just like all of our statistics have units, this expected value is an average, and it has units, which is the same units as our data. So what that means is, on average, if we look long term for this coffee shop, on average they sell 154.4, and it's okay to have a decimal because it's an average. It's saying it's not quite 155, but it's, you know, almost halfway to 155. So it's right in here somewhere, which makes sense because these two are the biggest, had the biggest probability, and then these counted less. Okay, so you could think of this as a weighted average. Okay, and that's what this formula says. So you don't have to use this formula if you don't like it. You don't have to memorize it. It basically says this procedure that we just did. So what this is saying, mu is the mean, or E of x, is you take the value, so this x is the value, scoot this down a little bit, and you multiply it by its probability. And then the summation symbol means you add them up. That's a capital sigma or summation. So this is a weighted average. Another example of weighted average is GPA. You know, when you take a 1 credit class, it doesn't count as much towards your GPA as a 5 credit class. So they would take your grade, the points for your grade, 4, 3, 2, 1, and then multiply it by the weight, the number of credits, and then divide by all the credits you have. So it's a weighted average also. Okay, so in the next video, we'll go over standard deviation. I'll see you there.